everyone, welcome to Power Electronics lecture number 7. And last time we have using RL from 0 to your SCI was off. We have a SCR. Right? Here is the output. So for this circuit, what we have analyzed it and these are the waveforms which we are getting. What is alpha? Firing angle and beta excitation angle. So what we need to do today is, last time we have seen the working of half wave control rectifier with RL load and we have drawn the waveforms accordingly. Today looking at the output waveform of half wave control rectifier with RL load, we are going to derive the output average voltage and average current. Right? So we have to redraw this waveform so that I'm not explaining that waveform. Please draw it in your books. Just now what you saw. These are the voltage waveforms across the wave or we how they are looking. Also write what is the x-axis. This is alpha. This is phi. What is this? Phi plus beta. This is beta. Yes. This is 2 phi, and this is. Why don't we apply a firing angle at phi plus? Why don't we apply? Yeah. Yeah. In the negative half cycle, the SCR is off only. So if SCR is off, in the reverse clocking mode, no use of. So this will be 2 pi plus alpha. What is one period? What is a period? Period is the time duration in which the waveform is reproduced. So what is the period over here? 0 to pi or 0 to pi? Yes. So 0 to 2 pi is my period. T is equal to 2 pi. Please mark that. This is what we are discussing. We are discussing control half wave half wave rectifier with RL load. We have already completed the explanation last time. Today we are just deriving the output average voltage. Now how do we define, let me just write it down as you have said it. Alpha is the finding angle or triggering angle or delay angle. And beta is the extinction angle. Yeah. At beta, your SCR naturally runs off. And what is that process called as? Line commutation or lateral commutation? because of the negative voltage carrying across the entire automatically. So this doesn't happen. This happens only in AC. Okay. First derivations for today will be, we have completed the waveforms. First derivation will be of V out average. Please write it down. V out average. What is the other name for V out average? Right? And what's the general definition? V out average. If I want to find average voltage, no, I asked general definition. 1 upon T integral 0 to T. Correct? Now you put result over there. What is 2 pi, right? And what is V in? Now you substitute it over here. And okay, I'll write V out average will be equal to, this will be 1 upon 2 pi, right? Integral 0 to 2 pi. What will come over here? Now tell me, from 0 to 2 pi, is my output, any point of time 0? Yes, from 0 to alpha it's 0, and from beta to 2 pi it's 0. So we can put the limits of integral as alpha to beta. Are you following what I'm saying? See, period is 0 to 2 pi, right? So from 0 to pi, my output is 0. Need not consider that. And from beta to 2 pi also my output is 0. So I can, instead of putting 0 to 2 pi, I can put alpha to beta. Okay, so write it down. It will be Vm upon 2 pi. This will be alpha to beta, and this will be sine omega t d omega t. That will be Vm upon 2 pi. What is integral of sine? Nahi, cos nahi. It's not cos. Minus cos omega t, right? Where omega t is going from alpha to beta. Now what will be the next step? It will be minus cos beta minus of minus cos alpha. Is that correct? So your V out average, the final formula will be Vm upon 2 pi into cos alpha minus cos beta. So this is the formula. This is the expression of V out average. Here we are discussing half wave. This is half wave rectifier still, controlled rectifier going on. So what is this called as? Average value of output voltage or average value of load voltage. It's one and the same. It's called as, write it down over there, average value of load slash output voltage. What will be average value of load current? Because resistor and inductor are in series, the current flowing through them is the same, right? So now, anyone? I out average? Yes. RL nahi. R. V out average upon R. So that will be Vm upon 2 pi R into cos alpha minus cos beta. So that's the expression for average value of load current or output current. Okay, completed. Shall we go to the next expression? This was A. So now we'll find out V out RMS. Please speed up your writing. And in the meanwhile, check everything is proper or no. Can we go with the next one? Okay. Next is, write it down, V out RMS. What is the general formula for V out RMS? 1 upon T 0 to T, then V in square omega T d omega T. That's it, right? The whole raised to half. Here again, T is 2 pi and V in is Vm sin omega T. Right? So let's derive it. V out RMS. It will be 1 upon 2 pi. Instead of writing 0 to 2 pi, can we say that from 0 to alpha and from beta to 2 pi, the output is 0? So the limits can be alpha to beta. Is that clear? So instead of writing again one more step, I am writing here itself, it's alpha to beta. Then what is V in square? Vm square sin square omega T d omega T, the whole raised to half. Achha, what is sin square omega T? 1 minus cos 2 omega T divided by 2, mathematical result. Okay, your sin square omega T will be 1 minus cos 2 omega T divided by T. So you substitute it over here and proceed, please. So V out RMS will be equal to, here you will have Vm square out because that's a constant. Then integral alpha to beta 1 minus cos 2 omega T upon 2, correct, into d omega T, the whole raised to half. Is that all right? So what will come over here? This 2 also, if I take it over here, I will get Vm square upon 4 pi. What is integral of 1? Omega T. And what is integral of, cos sine? So it will be minus correct now, because this 2 we have taken outside. And this will be from alpha to beta. Omega T going from alpha to beta. The whole raised to half. So V out RMS will be equal to, we can take this Vm square upon 4 pi as it is. Inside the bracket what will come? Omega T. What will come? Beta minus alpha. Then what will come? Sine 2 beta upon 2. Omega T we have to substitute, right? Minus sine 2 alpha upon 2. And the whole raised to half. Okay. So the final expression we can write it as follows. Vm square upon 4 pi, let it be as it is, into beta minus alpha plus sine 2 alpha upon 2 minus sine to beta upon 2. Bracket close, and the entire raised to half. Remember where I've written a beta minus alpha, those are in radians. And when the beta and alpha are with sign, those are in degrees. Okay? So here we can note it down. Alpha comma beta are in radians. So this is my expression. This is RMS output or load voltage. RMS output voltage or RMS load voltage. Both, they are both. Output and load is same. Completed? This is RMS load slash output voltage. Okay? Now, there is another, small parameter which we should know. Completed up till now? Let me save the file. Yeah. Completed? There is something, some people are writing still. Please complete it fast. There is something called as circuit turn-off time, which we have to note it down for this half-wave controlled rectifier with RL load. Can I go back? Yeah. In this, looking at this waveform, when is my SCR turning off? At beta. So at what point of time my SCR remains off? In a negative half cycle from 0 to, from beta to 2 pi, na? 2 pi plus alpha for the next trigger pulse. See, that trigger pulse is under our control. But naturally off kabhi ho raha hai. See, if we apply the trigger pulse at 2 pi, is there someone stopping us? We can apply, that is not a concern. But naturally turn off kabhi ho raha hai circuit? Beta. Beta to 2 pi ke liye off ho raha hai. So what should be my circuit turn off time? Let me write in orange color. Circuit, please write along with me. Circuit turn off time is denoted by TC, small tc. Will be what? This is x-axis is omega t, remember. So what will be t? This is the formula. What is the unit? Seconds. Why omega is coming? X-axis is omega t, right? And time chahiye to we'll have that. You understood why 2 pi minus beta? Because till 2 pi it is naturally turning off. Right? And beta is the time where it actually turns off. Completed? There is one more definition. Alpha is firing angle, beta is extension angle. There is one more, beta minus alpha. Just write it down somewhere. Maybe I'll write it down over here. Beta minus alpha is called as gamma, and this is called as conduction angle. Beta minus alpha is gamma, which is called as conduction angle. So what is alpha? Firing angle or triggering angle or delay angle. What is beta? Extension angle. And what is gamma? Which is beta minus alpha. But why it is called as conduction angle? You see, till from alpha to beta, your SCR is conducting. So that's why it's called as a conduction angle. Samjha? Simple? Yeah. What pi to 2 pi? No. When is the SCR turning off? At alpha, na? See, when SCR turns on, it will follow the input nature. देखो ना इनपुट नेचर कहां से फॉलो कर रहा है, फ्रॉम अल्फा टू बीटा and then it's again going off. Everyone understood? So shall we jump on to numerical? So let me revise in few seconds what we did so far. So far we have revisited the circuit of controlled half wave rectifier with RL load, and from the output waveform we have analyzed the expression of V out average, V out RMS and I out average, and we have also defined the circuit turn off time and the conduction angle. Alright, now based on this data we will solve the numerical on it. So write down numerical. So a 230 volt 50 hertz half wave rectifier, half wave controlled rectifier is triggered at a firing angle of 40 degrees, and the load current extinguishes at an angle of 210 degrees. Find the circuit turn off time Find part A, the circuit turn off time. You can watch the board. B, average output voltage. And C, average load current. Average load current for R equal to 5 ohms and L equal to 2 millihenry. For resistance R equal to 5 ohms and L equal to 2 millihenry. Okay? We have just now derived all the formulas, we'll use them. Now what do you mean by, first listen. We have to accumulate the data given to me, right? So first, before going to solution, let's write what is given. So what is 230 volt? V in, but is it RMS or peak value? So V in RMS is 230. What other information is given? Firing angle. What is that? Alpha is 40. And the load current extinguishes at an angle of 210. So what is 210? Remember, beta is always between pi and 2 pi. So between 180 to 360. So this is correct. So alpha is 40 and beta is, if I have to convert into radians, what I have to do? Multiply by pi by 180. So right now I have this information, and then we have R equal to 5 ohms, L equal to 2 millihenry. So now we'll start with the solution. So in short, this is the data given to you. Now first, the circuit turn off time. It is denoted by, let us write it down over here. What are they denoted by? TC. This is, and this is I out average. Okay, so let's start by finding out the value of TC. So what is the formula? 2 pi minus beta upon omega. Okay, how will you find out? 2 pi minus whatever. What is omega? 2 pi f. What is frequency given as? 50 hertz, right? So over here, this is 30 goes by 7 and 36. Yeah. So what I will do is Tc will be equal to 2 pi minus 7 pi by 6 divided by 2 pi into 50. So this I cross multiply, how much I will get? 12 pi minus 7 pi, right? Divided by this 6 will go down. So it will be 2 pi into 50 into 6. Just calculate now. Yeah, 5 goes 10 times, right? This is 10. So 1 divided by 10 into 6 and into 2. So 1 upon 120, which is how much? So it's about 1 upon 120 seconds. If I take it, I'll get it as 8.33 milliseconds, right? Is this correct? I told you beta and alpha are in radians. Don't substitute 210 over here. So this is my circuit turn-off time. Can we start with the next one? Next is V out average. What is the formula? Just now we have seen that Vm upon 2 pi into cos alpha minus cos beta. So what is Vm? 230 नहीं है, 230 root 2 divided by 2 pi into cos of 40 degrees minus cos of 210 degrees. Here don't substitute radians. Whenever sine and cos comes, it will come in degrees only. Now calculate this. This fraction will be around 51.77, and inside the bracket this I am coming out to be 1.632. So it's coming out to be 84.49, which is 84.5. Is this correct? So that's the answer. So average output voltage is 84.49. Correct it is? Are you all getting similar answer? Calculated? Next is what? I out average. Very simple. Whatever value you got, just divided by R. How much is R? 5. So 84.49 divided by 5 will give you how much? 16.898 amperes. Make no mistake, the average value of the output is in amperes. Yeah? Completed? Okay. Still half-wave rectifier topic, controlled rectifier topic is not over. We are left out with RL load with freewheeling diode, continuous and discontinuous mode. So after that we have RLE load. Then we'll go to full wave. So still 1 or 2 lectures are left to complete this topic. So everyone got their answers as expected? Yeah? So now please concentrate and let us start with, write down the heading, controlled half wave rectifier with RL load and freewheeling diode. Okay, so this freewheeling diode will be denoted by DFWD, freewheeling diode. Whenever I say power diode in power electronics, it means it is a power diode. Remember that, right? So this is a power diode only. It is capable of handling very large voltages and currents. And we have discussed power diode, right? When the power diode is on, it behaves as a short circuit. It doesn't drop any voltage across it. And when it is off, it is behave as an open circuit. We'll talk about that at the end. Let me start with this new topic. Everyone, ready? See, same controlled half wave rectifier with RL load hai, only with one more additional component. We'll see what effect it will have on the circuit. That's it. RL load, you have understood, right? Forward bias, I mean, when it is in the positive half cycle, what happens? Negative half cycle, why the SCR conducts still? Because the inductor store energy, returning back the energy, all that you know. Now we are just adding one more element. So draw the circuit diagram over here. Oh, I should use black. This is R, this is L. So where is my, is it visible the color? No? Let me use the orange color. Visible now? So this is your freewheeling diode. So I will have my current I in and current I out. Just one diode connected reverse across the load, and that is called as freewheeling diode. Okay? Shall we start? I'll teach you in comparison to RL load, ki how without freewheeling diode and with freewheeling diode, what is the effect. So for that, we should quickly draw the waveforms for, controlled half wave rectifier with RL load and without freewheeling diode. And then we'll study what happens in when we have a freewheeling diode. Okay? So for time being, y'all can watch it for without freewheeling diode and only draw the waveforms with freewheeling diode. Okay? So this waveforms which I am going to draw over here, this will be without. What is DFWD? Freewheeling diode. And this will be with. Okay? Blue color, red color is visible? Dark? Yes, no? Okay, now we'll quickly, I am not telling you to draw this, let's quickly draw that. So over here, if I want to draw this is, let's say my IG. How will my I in look like, I out look like? This is alpha, right? Correct? It stops at beta. And then again, it stops at 2 pi plus beta. Yeah? So what are these things? This is alpha, this is pi, this is beta, this is 2 pi, and this is alpha. So we have to draw that dotted line for beta. Okay, fine. Now this was the input, output current, load current, right? And in case of RL load, this was same as your input current. So input and output current are same in this case. Now let's plot the output voltage. We have already done that. I am just repeating this once again. So it goes from here to here. Then it follows the input up till where? Up till here. Right? I am redrawing it again. You all have already done that last time, right? So no need to do that again. Just watch it. I am doing it for comparison purpose. So this was V out. Correct? So V out voltage, V out waveform have a small negative portion along with a positive output. Is that fine? Now we'll start studying about your freewheeling diode and we'll draw the waveforms accordingly. Is that clear? And at the end we'll see the comparison between the two. Is that fine? Yeah. So let us start now. Let me make it separate. So that if something is there, I can draw it together over here also. Okay. Fine. So now tell me here, we have to do it by cycle by cycle, time period by time period. From 0 to alpha, what happens? Yes, 0 to alpha, what happens? First, yeah, tell me. Fast. So whenever we have, let's consider 0, when omega t is from what happens? Is my SCR on? SCR is in which state? SCR is in forward blocking mode. Off matlab it can be two varieties of off. If my SCR is in a reverse blocking mode, even if I apply a gate trigger, it will not turn on. It should be forward bias, right? So SCR is in the forward blocking mode. That means SCR is off. So SCR is in forward blocking mode. Means it is off, right? And when it is on, it is behaving as a open circuit. Correct? So will this, see, concentrate over here. If I have positive supply over here and negative supply over here, will it turn my freewheeling diode? Because for freewheeling diode to turn on, I'll require positive at the anode, negative at the cathode. So matlab during the positive half cycle, my freewheeling diode is never on. Matlab I can write over here, my freewheeling diode is off. Why it is off? Because it is reverse bias. Are you following? So can I redraw the circuit now in this condition? Yes. This is V in, this is RL, and here we have V out. And here we have a diode which is open circuit, correct? This is V out. Now tell me, will any current flow in the circuit? And which current will flow in the circuit? What will be the voltage across the SCR? VT1. Remember over here, by KVL, what we can write? V in is equal to VT1 plus V out, correct? By KVL, input is equal to voltage across the SCR plus output voltage. Now over here, what will be my output voltage? First of all, I in will be equal to I out will be equal to 0. If there is no current, no question of any voltage. So that means what? My output voltage will be 0. But what will be my voltage across the SCR? VT1. What it will be? Yes. So from 0 to alpha, these all things happen. Right? So let us do that thing over here. Please do it along. Please draw the waveforms along. Don't wait for me to complete and then you draw. So here we have applied Ig. So before alpha, this is alpha, right? So before alpha, what is my output voltage? 0, right? Agree or no? This is 0. What about my output current or load current? 0. Yes or no? What about my input current? 0. They are same now, output load current and input current. So everything is 0 now. Now what happens over here? Now we have to analyze the waveform from alpha to pi. Is that clear? Alpha to pi, what happens? Oh, this should be alpha to pi. What happens now to this circuit? At alpha, my SCR1 is triggered on. SCR1 is gate triggered. So it was in the forward for blocking mode, it will turn on. But will my freewheeling diode be on? No, because still we are in the positive half cycle. And we have positive half cycle, this negative is applied to anode. So that means it is off. So here what I can write? My SCR T1 is on. So it will be replaced by a short circuit. But what about the freewheeling diode? Is off. Okay? So if I redraw the circuit, it will look something like this. Please keep on writing along and draw the waveforms. Okay, this is my V in, this is my voltage across the SCR when it is on, right? This is R and this is L, and that's my V out. Now tell me, will the current flow in the circuit? Will this current be same as my input current will be same as my output current? Yes, loop hai na? Single loop it is, all are in series. So same current will be flowing over here, right? Agree or no? Now, we know in the back of our minds, we can write over here now, your I in my I in will be equal to I out flows, right? If this flows, what is my VT1 when it is on? Voltage across the SCR? 0. We are assuming now voltage across the SCR when it is on is 0. So VT1 is 0. What about V out? Remember, V in is equal to VT1 plus V out. If VT1 is 0, V out will be equal to, so what output will follow the input from alpha to pi. Is it okay? Now let us gather this information and apply it over here. So what will be my V out? Will follow V in till pi. Correct? What about I out? We know how our I out will behave in a RL load. So I out will increase and it will extinguish at beta. Agree? So this is my beta actually. Right? What will be my I in? Will I in follow the same nature? $12:30 is not over, na? Still we complete this and then. Anyways, lecture doesn't start at 12:25 or so. Now there is a break time na after that. Okay. What will be I in? Very important question. See, listen. Why I out is going from alpha to beta? We have already explained that last time. Because of the inductor which was storing the energy, it is releasing it back. And then it is, sustaining the current till beta. After beta, the current reduces to 0. But यहाँ पे क्या हो रहा है? Here is the difference. What about I in? You tell me about till pi. We'll draw till pi only. So till pi it will follow the same nature. Yes, na? उसके आगे क्या होगा? I don't know. So till pi I can draw that safely. Is this correct? Everyone agrees? From alpha to pi it is clear. Now next, from pi to beta. What happens from pi to beta? Tell me. Will SCR turn off? No. SCR will continue to conduct till beta. Why? Because of inductor stored energy. Inductor will act as an aid with the V in supply and that will keep the transistor on. So SCR T1 continues to conduct. Till omega t equal to beta. What is the reason? Because inductor is storing the energy, now it is helping to, releasing that energy during this period. So ये pi to beta क्या हो गया? हमारा input कहाँ पे जा रहा है? Input is going negative half cycle, right? Yes or no? So now in the negative half cycle, let me redraw the waveforms. अभी क्या होगा? SCR is on, right? SCR continues to conduct means what? It's on. It is still behaving as a short circuit. What happens to my freewheeling diode? चलिए बताते. Let us draw that circuit. This is V in. My SCR is on, right? I have RL load. Everyone pay attention. Now this is how the circuit will differ from the previous one. Pay attention what we'll have over here. So we have output over here across the load. R and L. We have to know whether that diode is on or off, right? Now let us understand. From pi to beta, what is my inductor doing? Inductor is releasing the energy. When inductor releases the energy, the polarity across the inductor changes, right? बराबर ना? We have discussed this, right? We are in the negative half cycle. So negative half cycle में ये positive है, ये negative है, correct? What about my inductor energy? Inductor is releasing the energy. So its polarity will be, अभी जब भी ये हुआ, when my diode is connected now, what it will do? ये positive anode को connected है, ये भी positive anode को connected है. What will happen? This diode turns on both due to the input supply as well as the voltage supply across the inductor, because it is releasing the energy, giving away the energy. समझ में आया? So this will turn on your freewheeling diode is forward bias. So when it is forward bias, it turns on. ये क्यों turn on हुआ पता है ना? And when it turns on, when a power diode turns on, how do we represent it? So if I draw a diode turning on, I can show like this. Okay, so I'll delete this from here and I'll show a fine, clear it is. Now see how the story will change very clearly. So no, everyone, what is this voltage? What is this voltage? VT1, correct? Voltage across the SCR when it is on is 0. What is my output voltage? The question is, what is my output voltage? Be clever. My diode is on. It's behaving as a short circuit. वो short circuit कहाँ पे आ रहा है देखो? Is it coming in parallel with the output? Yes ना? अरे ये short circuit क्या है? It will come in parallel ना, so output will be yes. समझ में आ रहा है कुछ? Did you understand this how output is 0? Because diode turn on हो गया, your freewheeling diode is on, the output becomes 0. No? Not understood. Did you understand how the freewheeling diode turns on? Freewheeling diode turns on, how it turns on, did you understand? That much? So whenever a power diode is on, it is replaced as a short. And whenever it is short, the voltage across the diode might be 1 volt or 2 volt. That is very small compared to 325 volt. So that's why there is a short over here. Now this short comes in parallel with output. So 0. यहाँ पे फर्क होगा. Freewheeling diode में output will never go negative. It will remain positive only. But now wait. What happens to current? Now अभी देखो, I am marking in red. Very crucial. Now please pay attention. Now this is my input current. Will my input current be same as output current now? Output current is still flowing. Remember, output current 0 नहीं हुआ है. Why? Because of inductor. Output current still flowing till beta. Now tell me, this output current and this input current, which was previously same when the freewheeling diode was off, are they same now? No. Now because my freewheeling diode is conducting, they will have one more current, which is called as freewheeling current. I am marking over here as this current, I call it IFWD, freewheeling current. Okay? Now you tell me, if I apply a KCL at this node, what will be IN? If I apply KCL at this node over here, let's say point A. So incoming current should be equal to outgoing currents. So what are the incoming currents? IN and plus is equal to, correct ना? Load current 0 नहीं हुआ है. Load current is not 0, it's still flowing. But what happens to IN now? IN का क्या होगा? What happens to IN? IN के लिए किधर फ्लो हो रहा है? IN देखो. For IN, your both SCR is on and this is also on. So what will happen to IN? Output is 0, agree? So let's draw that thing. Output is 0. So till 0 to, let me draw that beta value. Yeah. Let me draw that beta where it is. Here is beta. Okay. Now, what happens to iron now in this case? What you were saying? Iron will become 0 or it will sustain? It will continue. Acha, so no, this equation you have understood? In is equal to freewheeling diode plus I out. मतलब I in plus freewheeling diode current मिला के I out होना चाहिए. Now what is my I out? Flowing this part, right? From pi to beta. Acha, let us first draw output. Output will be, what will be output? Output will be 0 na? Till beta, right? Okay. What happens to, I out is drawn already. Now what happens to I? I have to draw forward current also. F, freewheeling that current also. What happens to this? In becomes like this. See now what I am doing. And whatever is the current over here left, it will flow through the freewheeling diode. Freewheeling diode current was 0 as long as it is off. But abhi on ho gaya to some current will flow na. So if you combine freewheeling diode current plus input current, it will give you output current. See the three together. अगर I in को combine करते हैं freewheeling diode से, you will get back I out. Is it not happening? So some part of load current is getting transferred to my freewheeling diode current, not to the input current, because input current to flow कुछ है ही नहीं ना, closed loop है. So input current will become 0, but my freewheeling diode current will come and it will flow like this. So this tukda, the freewheeling diode current plus input current will make your output current or load current. Okay? Yes or no? Draw this please till that time. Doubt? This is what? 2 pi. What is this? 2 pi plus alpha. Now what happens next? We are drawing it still. Now what happens next? We are discussing from, now orally tell me, need not go from beta to 2 pi, what happens? Are beta to 2 pi. My SCR is off now because input is negative and current is also 0. So my SCR will be off. What about my freewheeling diode? What about my freewheeling diode? Will it be on or off? कैसे ऑन रहेगा? नेगेटिव हाफ साइकिल. इंडक्टर वोल्टेज. So what will happen? That is what I am asking. Load current is 0 हो गया ना? Load current is 0. What do you mean by 0 load current? So in this case my SCR is off, so it will behave as an open circuit. What about my freewheeling diode? So now how will the circuit look like? Why freewheeling diode is off, off over here? Why freewheeling diode is off? Answer it properly. The reason being, listen here. Why the freewheeling diode is off? This equation. So now, in this loop, my in is what? What is my in? 0 na? Open circuit hai na? This is 0. This is 0. What is my output? Output is also 0. Output current, load current. Right? This is also 0. So it should add also key. This also should be 0. So whenever current flowing through the diode is 0, it is off. Right? That's why it is off. So in this case, what will be my output? 0. What will be my voltage across the SCR? V in. What about the currents I in? 0. What about the forward freewheeling diode current? 0. What about my output current? This is from beta to 2 pi. So let's complete that. Here it will be 0. What about the output voltage? Still 0. Yeah? Now last, then afterwards the cycle will repeat from 2 pi to 2 pi plus alpha. This is 2 pi, right? 2 pi to 2 pi plus alpha. What happens? My SCR is in the forward blocking state. I'm orally saying now from 2 pi to 2 pi plus alpha. So what is happening in this case now? My SCR is, we are back to the original condition. From 0 to alpha wala और ये वाला same है. This is similar to 0 to alpha. So my SCR is in the forward blocking state. So SCR is off over here. और ये positive half cycle है. मतलब मेरा freewheeling diode also is off. मतलब all the currents in the circuit will be 0. What about the voltage? Voltage also 0. So you continue to make this till 2 pi plus alpha. Okay, so in this case, your V out is 0, your I in is 0, freewheeling diode current is 0, then what do you have? I out is also 0. Because SCR is in a forward blocking state, it is still not on. When it will be on? When you apply a gate trigger at 2 pi plus alpha. So now, from 2 pi plus alpha onwards, gate trigger is applied. What happens? My SCR turns on. Listen carefully first. From 2 pi plus alpha to 3 pi. This is 3 pi, right? This is what? 2 pi plus alpha. So from 2 pi plus alpha to 3 pi, what happens? Yeah, your cycle repeats as it repeated from alpha to pi. So same thing will happen from 2 pi plus alpha to 3 pi. So now your SCR turns on, but your freewheeling diode is still off. So when the SCR turns on, output voltage will follow input voltage. Right? What will be the current? Current will go from 2 pi plus alpha to, what is this point? 2 pi plus beta, na? Beta is greater than pi only, na? So it is 2 pi plus beta. Automatically it will happen, na? Alpha it will start, beta it will end. If it starts at 2 pi plus alpha, it will end at 2 pi plus alpha, 2 pi plus beta. We know beta will be between pi and 2 pi. What 180 to 360. What about my input current? Again it will start rising, right? It will continue up till here only, right? And afterwards it will remain 0. When this will be active? ये pi तक ना, this value. It will get activated here and the cycle will repeat. So this is the working of uh, this circuit. Full half wave controlled rectifier with RL load and freewheeling diode. So what is the freewheeling diode doing? What was the freewheeling diode doing? Over here, remember, I'll come to that point now. But we have drawn the waveforms over here. Okay. Remember, in case of half wave rectifier without freewheeling diode, how was the waveform looking like? Waveform was like this, right? It was going negative. So this negative part is not allowed over here. The freewheeling diode, what happens? As soon as it is on, it fast forward the process of inductor releasing the energy. So fatapat. So as soon as your circuit is, so what it will do? As soon as the freewheeling diode is on, it will release the inductor energy in an instant. Earlier it was taking its own time, right, to release the energy. Now as soon as the inductor stored energy, whenever this diode is on, it will release that energy. It will actually freewheel that energy which was stored in the inductor instantly. So that's why it is called as a freewheeling diode. Are you understanding? So whatever waveforms we have drawn, these are discontinuous mode. This is discontinuous load current. What is the meaning of discontinuous load current? If my output current is going to 0, that is discontinuous, right? So it is discontinuous because I out was going to 0. Similarly, we have continuous load current operation. That we will discuss next time. Understood the job of a freewheeling diode?